Hey everyone, so we're going to continue our discussion with adding and subtracting radicals. We're going to look at some slightly more complicated scenarios. So just recall that when we want to go and start adding and subtracting, the first step is to actually simplify the radical first. So if we had something like this, we can rewrite the x to the seventh like x cubed times radical x, and the 4 would be square rooted to get 2x cubed rad x. Once we simplify both expressions, we then add them just like we would normally do with polynomials. Remember, they have to have like terms. So the key thing is that both the variables that they have to be the same, just like with polynomials, but now also their radical expressions also have to be the same. So in a case like this, they both have an x cubed and they both have a radical x. So I can combine it to get 3x cubed rad x. If this was a squared, because this one has an x cubed and this one would have an x squared, I would not be able to add them. All right, so keep an eye out for that. So here's the first question. Pause the video itself and we'll go over a second. All right, so going through this, what we're going to do is just like before, start simplifying all these. So the 98 can be rewritten as 2 times 49. X to the 6 is an even exponent, so I just leave it as is. Because this one's going to end up having a 2, I'm just going to check and I see that this, when divided by 2, gives us a perfect square, so 2 times 25. And this also gives a perfect square, 2 times 16. So now what I can do is take the square root of the 49 and rad 6 in each of these terms. So the 3/7 x still is there, but now I have times 7x cubed, and what remains in that exponent is a 2. Over here it's 6x times 5x cubed times square root of 2, and 5x times 4x rad 2. From here, I'm just going to simplify their coefficients a little bit. So I have 3x to the fourth rad 2, 30x to the fourth rad 2, 20x squared rad 2. Now here's the thing. Now that I'm going to try to combine them, they do all have a radical 2. But now I have to look at their variables. Only the 3 and the 30 have the same variables, x to the fourth. This one doesn't. So when I combine them, I'm only actually going to combine these two. And I add 30 and 3 to get 33x to the fourth rad 2. And I'm going to leave this negative 20x squared rad 2 off to the side. If I wanted to, I actually could take this one step further. I can do a greatest common factor and pull that out of each of these terms. So for example, each one could be divided by x squared at rad 2. So I actually could have written it like x squared rad 2 and then left as 3x squared minus 20. So this is something else that I could have done. You might want to keep an eye out for that because they might actually ask you to end up doing this later down the road. All right, here's the next question. Pause video work itself. We'll go in a second. All right, so this one's a little bit tricky. So they want to know the sum of all the edges of a cube. So if you know, a cube is the three-dimensional version of a square. So this is what the cube looks like as best I can. If we actually count the lines that I drew, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 edges. So if each edge adds up to 12, is 12 plus 10 rad 6, then what I can do is just multiply these two. Because what I'm going to end up doing is 12 plus 10 rad 6 plus same number plus same plus same. Adding up 12 times is the same as just multiplying it by 12. So I'm going to multiply this by 12, distribute to each term. 12 times 12 is 144, 12 times 10 is 120, and the rad 6 just stays there. All right, that's pretty much it. Right, here's the next question. Pause video work itself, and we'll go over in a second. All right, so now we're back into the independent practice. Just like before, we're going to do about 2 of these. So once again, we're going to try to clean up these exponents, rewrite them into their perfect squares. So this is rewritten as 4 times 6. This is 54 is 6 times 9, and 6 just stays there. So taking the square root, here 4 and x to the fourth are the perfect squares, 9 and x to the fourth are perfect squares, and the x to the fourth there are the perfect squares. So 4x to the fourth becomes 2x squared, and we have the rad 6 at the end. 9x to the fourth becomes 3x squared, and x to the fourth becomes x squared. So this is what I end up having. Then I just clean up the coefficients, so just multiplying these through. This becomes 3x cubed, this becomes 6x cubed, and this becomes x cubed. So if I look at this, I end up having a rad 6 and an x cubed in each of these terms. So now I can combine the 3, the minus 6, and the 1 together. So 3 minus 6 plus 1 is equal to negative 2. So my final expression simplifies to negative 2x cubed rad 6. All right, and here's the last question. Pause the video, work itself, and we'll go over it in a second. All right, so what we have here, when we simplify, the 72 becomes 2 times 36, and then the y cubed we're going to have to write as y squared y. 18 is just 2 times 9, y squared y, and the 98 is 2 times 49, y. Going through all these terms and square rooting the 36y squared, the 9y squared, and the 49, we end up having this. In all these, we end up having a leftover radical 2y in each of these terms. So when I simplify these with whatever they had in the beginning, I get 3y rad 2y plus 9y rad 2y minus 7 rad 2y. Once again, there's a rad 2y in each of these terms, but not everything has the same variable, y. So the only terms I can actually combine are these two. So I'm going to combine 3 plus 9 to get 12y rad 2y, and then the minus 7 rad 2y stays there. Once again, I could also just pull out, I could do greatest common factor again, pull out a rad 2y and rewrite like that, but I'm just going to leave it like this for now. All right, that's pretty much it. Again, the idea here with these questions is making sure that you're only combining the terms that have all the same like terms. So they have to have the same variables with the same exponents, and now they also have to add the same radical expressions. Before they didn't have that, here they will. So keep an eye out for that. Finish the rest of the questions. So you have a few more independent practice in the homework questions. So work on those and you can submit them later. If you have any questions, please let me know. Otherwise, I'll see you later. Good luck and have a great day.